In this question, we'll find the area between two curves using definite integrals. Before we begin the problems, let's look into the formula. The formula can be of two different versions. The general formula is considered along the x-axis, where the limits lie. And here you can see the upper function minus lower function. Limits are a to b. If you're using this, since this is in the electronic part, we are using the calculator method. You do not need to bother much about these functions. Only for some problems you need to know the graph. Otherwise, if you just find a and b, the intersecting points, the limits, that's enough. So let's solve this up. Here we have a simple problem. If problems like this comes, it is very, very straightforward. So you don't have to worry much on these. You have two equations. They both are parabolic. So it's something like this, and one is minus 1. Now we need to find the intersecting points. You do not need to know the diagrams as well. So all you need to know is intersection happens when both the equations are equated to each other. So imagine this is one graph and one more graph like this. Okay, and it's coming down. So when they intersect, both the equations are at equilibrium or equal. So here it's y is equal to y. So now in order to find the intersecting points here, just make them equal. So here this is going to be x squared minus 1, that's equals half x squared. Now we can use quadratic in a calculator, but we need to have it in quadratic form, that is standard form. Take this half x squared to one more side, it will be x squared minus half x squared minus 1 equals 0. And here, see, this is like 1x squared minus half x squared. So 1 minus half is half, positive half. X squared minus 1 is equal to 0. Now you can see this is in terms of ax squared plus bx plus c equals 0. The standard quadratic form. But we have b missing. So we have a, that is half, then x squared. Plus there's nothing in this. So it's 0. B is 0x. Plus it's minus 1, so I'll just write minus 1. So we can use directly the calculator and find the x values now. We are use mod phi and 3 for quadratics. So here you have your calculator. Mod phi is for equation, and you can see here there is simultaneous equations and then quadratic, then cubic. So I'll choose 3 for quadratic. The standard form was also given. You can see mod phi, the standard form is written here. It's half 1 divided by 2, or 0.5, and there's nothing in terms of x, and then we have minus 1. So the answer is root 2 and minus root 2. That's it, because it's a quadratic, only two solutions, isn't it? So now here there's an important thing you must do. You must write the smaller value first, negative root 2, then root 2, always in this ascending order, small then big. So here in the formula we have AB, first function minus second function dx. So how are you going to write this? It's going to be minus square root 2 square root 2, and over here the function, let me take it as x squared minus 1 minus half x squared. Now I'm not sure whether this is the right one. This is the upper function, this lower. It might be other way around as well, but doesn't matter. This answer will have a negative sign. That's it. So let's take our calculators. Whatever I type, you can see it over here, mode 1. Let's go back to mode 1. And can you see the symbol here just below alpha? That's the integral symbol. So I need to type the equations. X squared minus 1, close the bracket, minus half, that is 1 by 2, and x squared. And now close the bracket, dx. And what do we have here? Minus square root 2 divided by, for the upper limit, it's square root 2 itself. The answer is negative 1.8857. Now we need to simplify these. But before that, why is this minus coming? Because I have chosen the equations wrongly. This is the upper function minus the lower function. In the exam, you don't need to do it again. But now for just to show you here, I'll just rearrange them. So I'll just delete this out. Let me take that off and write that as the first equation here. Half. Okay, now that was a bad idea. Then we close the bracket. It's half x squared. So here we go. Minus the next one, you can see the answer will be in positive terms. It's 1 point, see one of the answer over here is 1.8856. 4 decimal points are enough. Now, which is the correct one? 4 by 3 is 1.33. So we can easily eliminate that off. This is not the correct answer. So let's try the next one. 4 root 2 divided by 3. Is it correct? Yes. So option B is the correct answer. But I'll just do the other ones as well. Square root 2 by 3 is wrong. And lastly, we have 2 by 4, which is also not the correct answer. It's wrong. So option B is the correct answer. I hope this is clear. Calculated method for simple problems, it's very, very straightforward. Now let's see another case. What if you have such problems? So here you need to again equate 5x by x squared plus 1 equals x. Now whenever you're solving equations in the denominator over here and all, don't just cancel this. No, don't do that. You need to have it in their original form as much as possible. You can multiply, but just don't cancel directly now. Because when you cancel it, you have to always consider x as 0 because you're cancelling from both the sides. So instead of that, I'll show you. Denominator, take it to the other side. Move to the other side. It'll be 5x is equal to x into x squared plus 1. Now when you multiply x, it'll be x cubed plus x. Left side is 5x. And now I'll move this 5x to the other side. So it'll be 0 equals x cubed plus x minus 5x. And the simplified one will be x cubed minus 4x is equal to 0. Now here you can remove x term common out, and then that will be x is equal to 0, and then simplify x squared minus 4 will be plus or minus 2. But instead of all that, I'll just use the calculator to give me the limits. Here, let's go to mode phi and option 4 for cubic. So when we go over here, say remember x squared term is not, this is 0 and the constant d is also 0. So option 4, it's 1 before x cubed. There's no x squared term, minus 4 for x, and there is no constant term, it's 0. The answer is 2, minus 2, and 0. The three answers are the smallest number, minus 2, 0, and then 2. So here we are having three limits. So it might be something like this, see? Because it's x, you know. So this might be the thing. You need to find this and this. There are two regions. So whenever you see there is only like this, if it's modulus, then it's a different thing. We'll study it later. But now whenever it's like this term, just x, and there are two terms, we have to use the integral 2 times. Why? Because there are two different regions. We have to find this area plus this area. And remember, the equation varies. If this, in the first one, this is up, in the next one, it's going to be down. So you don't need to bother which exactly is which. All you do is, I'm starting with 5x by x squared plus 1. Okay, I'm starting with this. And then I'm going to do that minus x. But over here, I'm going to do x minus 5x by x squared plus 1. This is it. You can't keep 5x by x squared plus 1. The same thing over here as well, because then it'll just nullify, it'll be 0. I mean, not 0, it depends, you know. From, yeah, usually it'll be 0 because this area minus that area. So that's why what you need to do, if you have chosen 5x by x squared as the first equation in one of the term, the one of the part, do that as the second in the next part. What about the limits? You start with the smallest limit, minus 2 to 0, and then 0 to 2. Remember, when you're adding the limits up and the second one down, limit must be equal. These are all the rules which we had studied before in integrals. So now we will just put this in the calculator. So here we go to integral, and then we have 5x divided by x squared plus 1, close the bracket, minus x here. And then what is it over here? It's minus 2 to 0. And then plus, you're adding it with, again, integral. So we will have to use x, because it's a single term, I'm not using brackets for x. But minus, when it's bigger one, it's better to put brackets. It's 5x by x squared plus 1, close the bracket. And then the limits are from 0 to positive 2. So what's the answer? Here we are getting minus. The reason is we have chosen it other way around. If you had taken x minus 5x by x squared plus 1, and then in the next term we had taken this, then you would have got the correct answer. So it's basically, if you change the limit, I can show you. But anyways, it doesn't matter which is, it's plus or minus, but only take the value. 4.047 must be the correct answer. 4.0471, it'll be 72. Now what next? Over here, I will have to solve each of this option and see which is the correct one. So let me try this. Oh, we are very lucky it's the first answer. That's it. That's the correct one. But I'll show you the other ones are wrong. Let me just put in the second one. See, it doesn't match. Or let me try the other ones as well. Over here it's minus 1 and 4. Natural logarithm over here as well, 4. So it's close, but it's not correct. Only the exact one is the correct answer. So over here it's minus 2. That's also wrong. Only the first option was the correct one. That was 5 natural logarithm 5 minus 4, which gives us 4.04718 and so on. So that's how we solve these. When you have 4 options, it's a bit easier because you do not need to stick to the exact equation, upper and lower and everything. So you have some liberty to choose your own equations and solve. This is similar to what we have done already. So I'll just run through these. See here, all you need to do is find the limits. Over here, when you solve, you'll get minus 2 to 2. And then this is the upper equation, but you can choose any, this or this. Your answer will be the negative or positive, but just take the value of it. That'll be the answer. So this is the figure, but if you look closely, it'll be minus 2, 2, and you can directly find it in the calculator even without graphing. And even this, we just did this. We got the answer here. And this one is also pretty straightforward. Okay, now we can solve this because over here it's x cubed, right? Let me just solve this up. First thing, x cubed is equal to 3x plus 2. I'll take this to the other side. X cubed minus 3x plus minus 2, not plus, minus 2 will be equal to 0. Now what you need to do is put it in the calculator. It's mod 5 and 4 for cubic. It's 1. There is no x squared term. It's 0, minus 3 and minus 2. So here then we have got 2 and minus 1. That's it. See, look over here. There's a repeating root. That's why. So it's 2 values itself. You don't have to do 2 sections. It's just 2 and minus 1. So here the limits, let's go to mode 1. The limits over here, let me just write minus 1 to 2. And then you choose any one equation. I'm going to choose x cubed, whichever was the first. I'm just going to choose that. Minus 3x plus 2. Now here, if you had not written the bracket, what happens is only 3x becomes minus. Then this will be positive 2, which is wrong. If you multiply the minus, it's minus 3x minus 2. So brackets are very important. So it's minus 27 by 4. See, the answer is 27 by 4. Why did we get wrong? Because we have chosen this wrongly. So in fact, even over here in the graph, you can see the linear function is above. So up minus down. What is down? It's x cubed. So that's the correct answer. I hope this is clear. Pretty straightforward problems. Even this one can be solved by yourself. It's not that of a deal. You just have to equate it, find what's the correct, what are the limits, and then put it over here. So here we go. And now this one is a very interesting problem because we have modulus. Now whenever you see this modulus sign, that means it is an absolute value function, right? The x value is like this. You generally will have only x, because if it's other than that, it's getting way too complicated. Then the limits or something must be given, otherwise it's very hard to solve it. So here you have modulus x. It's minus and plus, but look at over here. What is this? It is exponential function. Can this exponential be negative? You can put any number. You can try this. Put any number. The lowest number you'll get is 0 and something else. So I don't know how it is, but it can be like this, or it can be more than that, anything. So this is only from the zero, it's only from the right side, so you can ignore the left part. This is ignored, the left side of the graph, because we are only going to consider the domain to the right. Why? The intersection happens only at the right. The first function is having a domain from 0 or more, 0 to infinity. From 0 to infinity only, that's the domain. So in such case, both of them start at 0, so I know one of the intersection point is 0 for sure. But what is the other intersection point? If you try directly using calculator, you'll not get it. Let me show you. Now, what if I directly type this out? 4x multiplied by e to the power minus x squared, that is equal to x. Because I'm just taking positive x, modulus means it's minus and plus, both are there, but I'm not taking the left side, it's only the right side. Let me shift and solve, then equal to, see, I'm getting 0. Yes, that is intersection point, but we know that. But we are not getting the other answer. So how do we know where else it'll intersect? So what you need to do is you need to solve it manually, because the calculator wouldn't give you the answer. It's 4x. Now, how can you write this in terms of positive power? Because negative power exponents are very complicated. I'll write it as 1 by e power x squared, that is equal to x, positive x. So here, remember, we are trying to solve this to get this down. But before that, you need to understand this is, see, if it is e to the power minus x, it is e to the power x. It's the same thing. Or if you have, say, e to the power 2, you can write it as 1 by e to the power minus 2. So whenever you take it to the numerator, the sign changes from plus to minus, but now I had minus, I wanted plus, so that's why I took it down and made it positive. Now what next? I'll take it to the other side. That'll be x into e to the power x squared and 4x. Now, if I'm cancelling this, I should know x will be at 0. But, over here, this x, there's no other way of simplifying. So what I'll do is take this to the other side, because I need to get this down. And now I'll use log on both the sides. But I have to have the exponential alone at one side. So I'll take it to the other side. It'll be 4x by x. That is equal to e to the power x squared. This cancels up. Let me write it out over here. It's going to be 4 equals e power x squared. Now what? How do you remove this? This comes down. Basically, you have to take ln on both the sides, right? I'm going to do this step now. Ln 4 is equal to, over here also, natural logarithm e to the power x squared. Now, this cancels off. That is equal to x squared. And you have ln 4. Now, take the square root on both the sides. So, the intersecting point of x is square root ln 4. That's natural logarithm 4. Now, here I have done all the detailed steps, but you can directly solve over here. You don't need to do this. You might know, just take ln over here. This will come down, e dissolves directly over here, and the square root would be the answer. So you can skip some steps and get it. So now the limit 0, yes, I knew, but what's the other limit? It goes until square root ln 4. Now what next? Here then, one of the function 4x e to the power minus x squared minus x only. Why? Because this is only the positive side I'm taking, dx. Now what do I do is, see, I think so x should have been first, but doesn't matter. We are just looking for the answer, and you can just choose the correct option there. So we'll type this out. It's 4x e to the power, that is shift e to the power x squared. I forgot the minus sign here. And you have to close the bracket, minus x, and it goes from 0 to square root of natural logarithm of 4. There we go. The answer is 0.806. And here, okay, this is the answer. So what we need to do is write this answer down. 0.8068. You do not need to, approximate to the nearest 1,000, 10,000. I'm just writing 4 digits, not going to round it off or anything, just written it. Now we need to solve all the 4 options. Now here in this case, it is ln 4, the correct answer itself, divided by 2. That must be equal over here. Yes, that is correct. So this is how we can easily solve it using calculator. Now when we are exponential on one side, we know, see, the graph will only have the domain of positive x values. Now what, okay, over here, this is another very useful example. Here we know the left side and the right side. This is the absolute value of x. And this graph, I'm not sure how it is. It might be some, okay, it's x squared plus 1. It's not a parabola. It's something like this or something like that. Okay, there's two important things. In such cases, when there is modulus, you will have two parts. See, now from here, whatever is this limit to 0, and from this to this, there's two different intervals. So we have to use integral twice, isn't it? We are using integral twice with the limit. But since it's modulus, don't change this up, down, down, up. No. Whichever you're chosen, like what you do is just choose this as the first term for both. The best way would be like this. Okay. Now, when you take this, I know the middle intersecting point will be 0. Why? Because it is modulus x. So here it will be 0 and up to 0. So this left side, right, will be minus of minus x. Why? Because when you see the left side, what is that part? Modulus means it is having plus and minus x, isn't it? It is valid for both. It can be either plus x, minus x, depending on it. So x, so it's basically x is equal to plus or minus x. That's what it is. So whatever is x over here, first one, when you take the left side, the negative limit, you have to take minus, and then over here it'll be minus x. So basically this becomes plus. But I don't know what are the limits. So how do I solve them? So you need to solve them like two times, but I'll show you now here. It'll be 2 by x squared plus 1. That is equal to, first time let me take minus x, consider its left side. Now it'll be 2 is equal to minus x times x squared plus 1. I multiply it, it'll be 2 is equal to minus x cubed minus x. And I can rewrite this. I'll take these two to the other side. It'll be x cubed plus x plus 2 is equal to 0. The same thing I have to solve again for plus x. Why? Because it's either left side or right side. And that is going to be, this is the now right side limit. It'll be 2 is equal to x, directly I'm going to multiply x times x squared is x cubed plus x squared, and I'm just going to leave this over here 0, take this 2 to the other side, it'll be x cubed plus x squared minus, sorry, it's not going to be x squared, it's only x minus 2. And now solve it up using mode phi 3, sorry, not mode phi 3, it's cubic, mode phi 4, and you'll get the answer. So here mode phi 4, let me type in 1, 0, there's no x squared term, 1 and 2 plus 2 itself. So the answer is minus 1, and ignore the others, it's imaginary, it doesn't matter, but minus 1 is the point here. So I'm just going to write the limit, it's minus 1 to 0, and so it's going to be plus 1 in this side, you know, let me show it. Mode phi and 4, it has to be 1, 0, 1 and minus 2, it will be positive 1, and then imagine numbers. So here it's 1. I hope this is clear. Now then, when you put in the calculator, you will get the final answer. All we do is this integrals mode 1. Let's go back to the computation mode, integral symbol. From here we have 2 divided by x squared plus 1 minus of minus x. Close the bracket, and the limits are from minus 1 to 0. Plus, again, integral 2 divided by x squared, it's alpha x, squared plus 1, and it's minus x only. And it is from 0 to 1. The answer is 2.1415, and you can see it is, just write it, I'm going to keep it in my mind, but you can write it down. And here it is pi divided by 2 minus, here we have pi by 2 minus 1. I did double check this. It should be 2.1415. This is wrong, this answer. Over here, you can do it manually and check it. I did it manually and checked it. Whatever the answer we got is the correct one. So I'm just going to write it out over here. Let me clear it out. The answer for this will be 2.141592, and it goes on. So that's the correct answer. I hope that's clear. And so this one we have already done in the second MCQ. This was, you have to take one part, this part first minus the second part, but in the second integral, you swap them, not the same thing. So here we go. There was 5 ln phi minus 4. See, this is how the graphs are. And this is the down. This equation was down and the linear function was up. The second one, the rational function was up and the linear function was down. Okay, we have a trigonometric function. This is an interesting one because they've given us the limits and we need to find, okay, now this is going to be not tricky because we need to find all the intersecting points of sine and cosine between 0 to 2 pi. Now, if you know the unit circle, it's much easier to understand. I know 45 degrees for sure. It's always 45 degrees. And then over here, if you go back, it will be 180, 225 degrees. At these 2 degrees, what happens is they are same. Sine and cosine are equal. That means that's the intersecting points. From the unit circle, we know the formulas over here are the same, or you can try to graph them like this, and then you will see where it touches. That'll be at 45 degrees and 225 degrees. But here, they are also given the closing limit and the ending limit, start and ending limit. So there'll be lots of intervals. It'll be from 0 to 45. So I'll write over here 245. Then we have 45 to 225. And then 225 to 360 degrees. Here you need to get this all in terms of pi. It's better to keep it in pi because here then we can just keep the radian mode and solve it up. I'll show in calculator how we can change them from degree to radians. To convert from degree to radian, it's pretty simple. Whatever the answer you have, 45, just divide by 180 because 180 is the pi value. Now this is in terms of pi. So what you can do is basically 45 by 180 into pi. So it's 1/4 pi. Now if you want to find 225, just write 225. Oh, it's 225 divided by 180 times pi. It's 5 pi by 4. You can see these values here. It's 0 to pi by 4. Pi by 4 to 5 pi by 4, which we got. And 5 pi by 4 to 2 pi. I'll just write the intervals. How it will be is, first thing will be 0 to pi by 4 plus, next one will be pi by 4 to 5 pi by 4. And then last one will be 5 pi by 4 to 2 pi because these are the ending limits. So now one more thing is, whichever is first it'll keep on alternating. So now what I'm saying is, see here, the first one is taken as cos, then sine. So in the next you should take sine cos, then again cos sine. Now I'm going to change it to the other one. Instead of cos, I'll take first one as sine. But always remember, in trigonometric function, cosine starts from up above, sine starts from down. So first one will always be cosine, but I'm just going to change it from sine x minus cos x. The next one will be cosine x minus sine x, and lastly sine x minus cosine x. I'm not writing dx and everything. Let's put this thing in the calculator. So now here it'll be integral sine x, close the bracket, minus cosine x. Then we start from 0 to pi by 4. So 0 to pi divided by 4. Then plus. Now since we had used sine, I'm going to use cosine now. Cosine x, close the bracket, minus sine x. And then we start from pi by 4 here. Shift pi by 4. And we have 5 pi by 4, 5 pi by, okay, I pressed something wrong. Let me go back. Pi is shift and over here divided by 4. Okay, I'm doing too many blunders now. And plus the last interval It's again sine x, close the bracket, minus cosine x. And it is 5 by 4 pi to 2 pi. That's 360 degrees. Now please remember, it should not be in degree mode, it should be shift mode 4 to radian. And here we go, the answer is minus 5.6568. Why is it minus? Because I chose the other way around, isn't it? Now let me show you what is the exact answer. It should be 5.6568. 4 root 2 is 5.6568. The only thing is I purposely changed these values. I was not in order, though it's a common thing. Cosine is always up above than sine when we start. When we begin at 0, it's always up. So then just alternate it out. That's how we solve it. You can see the graphs here. Cosine, it starts from 1 and then it goes, and you can see at 40 and 225 degrees, they do touch each other, they intersect. And then we stop at 360 degrees because I've given it's 2 pi. So that's how we solve this out. That is the end of this question. I hope it is clear. If you have any doubts, please consider rewatching the video or posting your doubts in the comments. I hope you all will head on to the next video.